I want to introduce our guests today for this fireside. With us, we've got Annie Sullivan from Google. Annie, I'm super excited to have because I was chatting with a good friend of mine in the web performance community, and he was like, you know who you should get for this discussion, because we were talking about the gamification of metrics, like using Lighthouse and stuff. He's like, you have to get Annie. And so we reached out, and thankfully we managed to get you. So super excited about that. And with Annie, we've got Rick Klein, who's an engineering manager on our real user monitoring team at Datadog. So they're going to be talking about modern web performance, what you need to know, how you should measure things, and everything that's important. So give them a big welcome to the stage.
So real quick, Annie, do you want to talk about what your role is at Chrome?
Yeah, so I'm a software engineer at Google on Chrome Web Platform, and I lead a team called the Chrome Speed Metrics team. And we work on the core Web Vitals metrics and web performance APIs.
Cool. And for context, I manage the RUM SDK teams, both mobile and browser. But for this conversation, my team is responsible for the client-side collection of the vitals. So how we turn that into like the dashboards you see on Datadog. So let's get into it. So we're going to talk about core web vitals, and I thought it would be a really good kickoff point for you to just tell us how we got here. Why do these exist? Where did they come from? Why should I care about them?
Yeah, so we've been working on speed for a really, really long time on Chrome. And over the years, we've really focused more and more and more on like what is the real user experience? What are end users seeing as opposed to what we see in a benchmark? And then what are the actual user journeys, like loading a web page, interacting with the page, things like that. So the idea of Core Web Vitals is to really, as much as we can, standardize the metrics. Like what is the actual user experience of loading a page? What is the actual user experience of like clicking or tapping? Also layout shifts, right? One of the most frustrating user experiences when things jumble around on the page a lot. So our idea was to kind of standardize that and then make the data available to everybody. So we have web APIs that RUM providers can use, and we have the Chrome User Experience Report, which will tell you your scores for real Chrome users on these metrics. And then also we have a ton of tools that help you debug them in the lab.
Cool. So if I understand correctly, Web Vitals became an official thing with an official tag in like May of 2020-ish?
Yeah, we announced them, I think, at Google I/O in May 2020. And then in, I think, August 2021, we kind of like made them really official.
Cool. And there's three, right? Back then there were three: LCP, FID, and I know I'm using acronyms. We'll get there, I promise. And CLS, right?
Yeah.
Some of those change. We'll cover that a little bit later. But why those three?
So we wanted to kind of take the most broadly applicable user journeys on the web and user experiences and try and really narrow down focus on just a few things. At the time, in like 2019, I think there's so much happening in the world of web performance, which is really exciting. But any time that somebody found a new way to measure, a new way to debug, or a new way to kind of structure data, they would have a new metric. And there were like dozens and dozens of different metrics, and it was really hard to figure out like what to measure and what to focus on. And so the whole idea of Core Web Vitals is like there's a couple user experiences that are really important. Loading a page is just really critically important. Interacting with a page is very important. And then like the experience of the content shuffling around on the page is a very negative thing that we hear from a lot of users. So we wanted to really kind of narrow things down and make it easy to focus.
Cool. Speaking of focus, let's move on to LCP. So LCP, this is effectively, the TLDR is like page loading effectively.
Yeah, that's the user experience we're trying to measure is the page loading. And then largest contentful paint is kind of a standardized specification for how we measure it in a way that's really focused on user experience. Previous metrics like the onload metric, that's like when all of the sub-resources in the original document are loaded. That doesn't necessarily correlate with anything the user sees. And when we looked at large-scale studies and we had metrics like LCP and speed index that are kind of more focused on when does something actually show to the user versus those other metrics. And LCP is like much more correlated with user experience. And it's also easier to measure and standardize than other metrics that are focused on like what does the user see.
So you said other metrics a couple times, and I'm pretty positive you're referencing like first contentful paint.
Yeah,
So you purposely picked LCP over FCP primarily because.
well, first contentful paint was our very first attempt to say, what is that actual user experience? When does the user see something? And as the name implies, it's the very first contentful paint. But web pages kind of load in, as you know, over time. So the first contentful paint could be a very long time from when the main content of the page displays. Largest contentful paint is basically just the largest image or text on the page, and it's a really, really good proxy for when the main content of the page is loaded. And first contentful paint is still really useful for debugging. Like, is your page painting? Is it starting to show? And then is the largest contentful paint much later, or are they kind of more similar?
So one of the things that I've always wondered is that, like, as a web developer, I really like to push new tabs for a content that isn't like, I want to keep focus for what you're working on, but Datadog does this a lot. We open a lot of things in new tabs. How does tab visibility impact LCP?
Yeah, so specifically when something's in a background tab, Chrome and probably lots of other browsers try to really focus on the foreground content. And so that means that we might evict the page from memory entirely. We might load it very slowly because you're doing something on the current page. And we don't want developers to stress out about that. We think that's important, but we don't want you to try to have to optimize around Chrome de-optimizing your page. So if any part of the page is loaded in the background, we don't count that LCP as part of the Chrome user experience report. So that's an important thing to realize, is that we're really focused on foreground page loads and what's happening right in front of the user.
So let's talk about a real world example. I've been a manager for about 10 years, but every year I try to challenge myself to recapture my deploy keys and try out some of the latest tech. Most recently, I started building a Nuxt.js app because I know about it, but I've never built anything with it. And my first run, I'm kind of embarrassed to say, my LCP was like 11 seconds. If I have an outrageous number like that, where should I start looking?
So is that a RUM number, a lab number?
It's a RUM number.
Okay, so a RUM number, just to recap, that's real user monitoring. So we're seeing that number from real users in the wild. And what's really great about real user monitoring is that you don't just get one number, right, your largest contentful paint. My team works on web performance APIs, like navigation timing. They give you a lot of different data points. So the first thing I would look at is, when was the time to the first byte? So that's basically, when did the web page start coming back from the server? If the time to first byte is like 10 seconds, then you know there's a problem on the server. If it's like 500 milliseconds, then you know there's something else happening on your site, like maybe some sub-resources are loading slowly and blocking the load. So that's the first place I'd look.
It's pretty funny you bring that up, because one of the things I didn't realize is that Nuxt servers actually take some pre-warming. So my site was basically locked on getting an API response from the server itself, only the first time. But because I'm a manager and I'm doing this between 5 minutes between meetings, I basically only ran it on a pre-warm instance over and over and over again, which is how you end up with a P75 of 11.22 seconds. So it turns out if you have more than 5 minutes between meetings and you run it twice, it actually goes all the way down to 1.19, or you could actually, pre-warm your servers. So good catch there. I'm going to pause there because we've talked about LCP quite a bit. Jason has 2 mics, and we'd love to hear any questions about LCP, or maybe some of the history of the Web Vitals, if anyone has any. If not, don't worry, I have plenty of content to fill the 40 minutes. Do you want to grab the mic?
So this is regarding LCP. Especially, we don't have the comfort of building brand new systems. We have ERPs, and we drive data from ERP systems to the customer facing. So our LCPs are high too. So apart from pre-warming, any other solutions that we can implement, given the fact that we don't have much liberty on pulling the data?
Yeah, so you're saying there's lots of RPCs coming from
Backend systems, yeah.
Different places. I think one thing to really focus on is really understanding what is the user journey and what's the most important thing to the user. Rick and I were talking about dashboards. We both have like Chrome internal dashboards I have and the RUM dashboards, right? And there can be like really slow requests to get you the data that you need from the server. And I think really trying to understand your users and like what's the thing they want to see fast. Can you cache that part? Can you show that part up front? And then load the rest dynamically. It's hard to give like a very specific answer without a specific use case, but in general, really trying to focus on the user journey, what's most common, what do you need to prioritize, and try to prioritize the most important things.
Yeah, and one other thing, just sharing my experience here, one other thing we also seen is you have your applications running in US and someone is trying to access from Australia. That also impacts it. The other factors that we have, again, thanks to Datadog, like we've been extensively researching on this. The other factor that we have seen is Chrome has the ability to download chunk files, especially the JavaScript chunk files. I was told that it can do only 6 at a time, or like on the developer tools. So that also impacts the amount, like, so it keeps shifting the LCP because it can only download certain packets. So your LCP will increase. So my conclusion so far is that it's not single factor that you can rely on, especially to bring LCP from 11 to 2 or something. So came to around 4.5, but still not to the green part of it.
Yeah, you really have to look at like, I mean, think about it as a critical rendering path. There's the initial response from the server, and then you have like JavaScript files that you might be dependent on. And if the number of files in parallel is a problem, like you can see that Web Page Test is a great tool, or Chrome DevTools Network Panel, like how are things being downloaded? And you can think about combining resources or making them smaller, delaying some, depending on what is blocking the critical path most of the time.
Cool. Thank you.
I actually have a piggyback on this question. What does the UXR say about it being 4 seconds, specifically being the cutoff between needs improvement and poor? Is there any insight there of like, oh, we see the majority of users at 4.1, just like close the tab or something like that? Or can you maybe explain why 4 and why not 17?
Yeah, so there is no perfect UXR on exactly like how fast a page should load, but we kind of took 2 things into account when we set our thresholds for core Web Vitals. One is the UXR, right? Like there's a lot of UXR around 1 second being really good, and then 5 seconds being really kind of very bad. And then the second thing we took into account is achievability, right? Like how hard is it to get to 1 second? And right now it is just too hard to get to 1 second. Is the reason that we set it to 2.5. I think it's really difficult, if you have users in Australia and in Europe and, like cross geo and things like that. So we do take achievability into account. And that's where we kind of looked at like the curves of what people are able to achieve. And we kind of saw that it's pretty easy to get past 4 for the vast majority of sites.
And that's also why we probably do P75 and not P99.
Yeah, yeah. There's always going to be outliers on any site, and so we look at P75 so that like some weird case doesn't really have that much of an impact.
Cool. I think we have time for one more question. If anyone has a question on LCP, if not, happy to move on.
Kind of a 2-part question. So you talk about the largest image or the largest text block. Do you take into account for the largest image, maybe a CSS rendering it way smaller? And then for the largest text block or largest image, what happens if that's below the fold?
So yeah, 2 parts. If it's way smaller, we look at what's called the image's intrinsic size, and we base the largest on that. So if you have a 1 pixel image and you blow it up to 300 pixels, and that's like the largest image on your page, we count it as 1 pixel so that people don't try to like make weird blown up images and have it like screw up the metric. And then the second thing is we only are counting above the fold content. So we really, some pages are like really, really long and they load like as you're reading them, and that's really fine. We're really looking at like, when can the user start like reading the content and interacting with the page?
But it's not like content past the fold has no impact on your Web Vitals, right? There's definitely like, even like because of like blocking the main thread and stuff like that, there's definitely ways that content beyond the fold can impact your Web Vitals, right?
Yeah, totally. So we really advise people to prioritize above the fold content, and that means a couple of things. If you look at image lazy loading, right? If you're pretty sure an image will be below the fold, you should lazy load it so that it's not taking up network to load. And then also you should think about if you do have like kind of components or things like that in your page, you can lazy load ones that are below the fold.
All right, let's talk about CLS. So this is measuring visual stability, basically. Like what you're trying to avoid as a developer is having a bunch of jank, which I believe is a technical term for just all these elements moving around as it's loading, right? So how do you measure this? Because I truly, I've read the RFC multiple times, and I feel like I need an ELI 5 of like how you actually measure this.
Yeah, so basically what we do is we look at content that like, as things are painting on the page, like what unexpectedly shifted from frame to frame. And in every animation frame of the page, we kind of look at like all the content that's moved around that probably shouldn't have, like an ad popped in and then a bunch of content moved down, right? And essentially it's like the percent of, the score for the frame is the percentage of the page that moved. So as a fraction, like from 0 to 1. So if like an ad pops in and 10% of the content shifts down, you get like a 0.1. Does that make sense? And then the thing is that makes CLS hard is that usually when something pops in and things shift around, they shift around over multiple frames. So you see like chunk, 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 chunk. And that like multiple frame experience is actually like way worse than like one single frame. So what we try to do is like add together all of the moving around that happens in like up to a 5-second window. And the worst burst of content moving around is your CLS score for the page.
Gotcha. So I guess the low nuanced way of doing this is I'm just going to add skeletons or preloaders or people using gray boxes, if you will, to all the areas where I'm dynamically loading content, and that way nothing shifts. Is that as easy as that, or is there more complexity behind it?
It isn't. It's even easier, right? Like if you have just a basic HTML page, there's kind of two basic sources of shifts if you don't have dynamic content. One is just not sizing your images, and we find that like we wrote a Lighthouse audit that just checked if images were sized properly. And we ran it on like our HTTP archive million sites, and we found that one thing alone would fix most CLS on the internet. So start there, size your images. And then very similarly, if your font is really far off in sizing from like the system default, it'll cause a really ugly pop for users who don't load the font right away. So try it. There's sites that can help you like match up the font you have to like a good default. So those two things make a huge difference in CLS. And then if you do have like a lot of dynamic content, reserving space for it is great. And sometimes people get like really frustrated because they can't be 110% certain about exactly how wide and tall the content is. But like I said, the CLS score is based on the percent of content that moved around. So if you mostly get it right, and sometimes there's a little bit of extra shift, you'll get a way better CLS score if you try to reserve some space and you only get it right most of the time.
So Andy, one thing is with all the new frameworks coming out, SSR and SSC are becoming increasingly popular. So why is CLS going to still be a thing even with SSR components and SSD, right? If we are rendering all this on the back end and we're serving it completely rendered, we don't expect it to change. This is going to be zero for everybody, right?
Well, so SSR is super exciting for performance, right? Because you can render everything on the server, it comes right down, it streams in as HTML, and then when you hydrate, ideally, like the content doesn't change at all. And so where we're seeing people have problems is like sometimes you don't know everything on the server, right? And you go and you hydrate and the content changes. So I think this is like the biggest problem for SSR and CLS is that the content can change. I think being aware of that when you're debugging is like the #1 thing. Just trying to understand how that happens and when. It's a little bit frustrating because it can be really specific to your individual use case. But remember that is like a real user experience, right? Like the idea was that we rendered this content really fast and then nothing changed and the user just had this seamless experience. And if your site is rendering once and then rendering something different, that's a very confusing user experience. So it is something to really think about with SSR.
Yeah. One of the things that I remember from the olden days of 2015 when server-side rendering was like the twinkle in the eye of most developers, was that like even some of the technology stacks that we use just didn't support it. You couldn't access it from server side. And specifically, we were using the site that I was working on at the time when I still had the ability to make commits was so Firebase, their real-time database. We were using a real-time voting like game type thing. And we'd have to server-side render everything but the voting mechanism. And then when we rehydrate, make the connection to Firebase's real-time database. And then that introduced a whole bunch of layout shifts because we didn't know if there were going to be 7 participants, 2 participants, 1, 7, 50, whatever. So I think that's another thing to consider is like how, like what is going to load once you hit the browser is like a real big consideration because we've come a long way on SSR, but there's still a bunch of things that just don't work in SSR. Sorry for the rant. One other thing I wanted to ask is thinking about LCP and CLS. Both of these things basically encourage you one way or another, either directly or indirectly, to basically have predictable layouts. So it's like the general recommendation from Chrome and from the Vital team is like, try to make your site as predictable as possible, even just to kind of drive these numbers as far down as like a general statement.
Well, I mean, it's not necessarily a recommendation, but I think when you think about performance, the more that you can cache things and preload things and predict things, the better, right? That's why static site generation got so popular is like instead of having to construct the site on the server, we realized that a lot of time it's dynamic to the developer, but you can pre-build that site and cache the whole thing on the server. So the more things are static, the faster they're going to be for sure. But if you do have dynamic content, like really think about, I've seen a lot of UXR around, for example, LLMs, right? Like you're going to have this content pop in. We probably should have like the user will know where the content pops in and when the content pops in and they're waiting for it, right? It's probably better, like most LLM apps have like, you type and then you can see the thing is about to bring something back in and there isn't a lot of layout shift, right? So I think that making what can be static is great. And then really thinking about the user experience of the more dynamic content is also really important.
Yeah. For those wondering, which I'm sure is nobody, my CLS score on my Nuxt.js app was 0.032. So pretty proud of that one. And with that, I'll take a pause. Anyone have any questions on CLS? I guess we nailed it. All right, let's talk about the new kid on the block, IMP.
All right, so first question I think I get is what happened to FID? So let's talk about what is FID, what is IMP? Let's take a step back. Remember, we're trying to measure what are the most important user experiences. And the user experience we want to measure here is just interacting with the page. When we developed the Core Web Vitals, we had a big problem where basically like that first interaction, there was so much JavaScript running that it was often like the event handler for the first interaction almost always had like a big delay before it could run. And we were also a little bit more focused on mobile where JavaScript runs much more slowly. So we really wanted to just give developers a bit more of a focus on like where can they improve. And so the first metric we had for user interaction was called first input delay. And basically just the first time the user tap, click, whatever, we just waited until that event could be processed and we saw like how much is that. And it's been really exciting in the last few years to see developers just knock that out of the park. We went from about 80% of sites when Core Web Vitals launched having a good score on FID to over 99%. So awesome job, internet. But we still have a problem with interactivity on the web. About 90% of user time on a page is spent after it's loaded on a generic web page. And 1 in 100 user interactions, the UI just completely freezes for over a second. 1 in 100 pages have an interaction like this, both on mobile and on desktop. So we really wanted to make sure that we're continuing to help developers address interactivity problems, and we kind of advanced the metric to interaction to next paint. What interaction to next paint does is it looks at all the interactions on the page, and it says from the time I tap, click, or press a key until there's just the next paint. how much time does it take? And ideally, it's less than 200 milliseconds. The UXR on that, again, is 100 milliseconds, but especially on the one mobile, it's not really achievable necessarily today. And again, this is just like the first paint after the tap, which is kind of like the immediate response. So we've seen a lot of pages where, for example, like you click a button and there's a depressed button style. And the page freezes for so long that the button never gets depressed. So like there's no user feedback at all. So this is what we're trying to measure with interaction in XPaint.
So when I saw the announcement and when I read like a lot of the feedback, there's like a lot of focus on the fact that IMP seems to be an acknowledgement that SPAs are real, and that the majority of the web is written using SPAs, right? Historically, Web Vitals and like Lighthouse metrics and page speed insights have been so focused on like that initial load that you know, that made sense for multi-page applications, and like when we were writing PHP scripts to load DOM elements, like that made a ton of sense. Is there more to like SPA based, or I'm kind of inferring here that IMP is SPA based, but tell me about like the interactivity between IMP and SPAs, and is it like an admittance that like the majority of apps are written using SPAs?
I think that SP like is almost it's a single page application. That's when you load one page, and then it's a full application, and the user like continues in that initial navigation for the rest of their user journey. And I think what's really complicated here is that like a lot of these new technologies you're talking about, new frameworks, new server components and stuff, they're really blurring the lines between a multi-page application and a single page application. There's almost no pages, like I said for CLS, right? Like just make your HTML good, and that's static content. And there aren't really a lot of pages that are just HTML though. Most pages have like a menu that you can interact with, and they have third parties that are doing work. Like most pages have a lot of interactivity, and like I said, like the median page, 90% of the time is spent after a load. So definitely SPAs are something that we need to be measuring, but it's also just there's like a lot of like app-like interactivity on almost any page these days.
Are there specific SPAs that like I'm not saying recommend, but rather like as you're trying to design the next performance entries and the next vitals, like do you start with React and then look at Angular? Obviously, probably being a goal, you probably go the other way, but basically, like, are there a set of technologies that you're looking at and what they're doing for performance, and kind of tailor some of your decisions based on that?
So we do try to look at like the biggest frameworks and try to like when we make a new metric and when we make a debugging API, one of the things we do is we try to like look at all the different use cases, right? The internet is huge, what's happening. So we look at larger frameworks and say, like, what is the IMP for these frameworks? Is it good? Is it bad? Like do we believe that it's accurately measuring all these different technologies? And we do that for different verticals too. Like does it work for news sites? Does it work for shopping sites? But one thing that we really do try to do is be framework agnostic. We look a lot at what is kind of up and coming. There's a lot of really exciting things happening in the framework world right now, like server components, but also like just dynamic ways of loading content. And we want to make sure that we're measuring the user experience accurately as things change. So a lot of times that'll end up with us looking at much smaller but more novel ideas and trying to make sure that we're supporting all the different directions that things could go.
Cool. Actually, like that actually hits most of my IMP questions. So I want to open up. Does anyone have anything to ask about IMP? Go right ahead.
How are you actually measuring IMP in practice, like in the real world? Do you collect browser telemetry?
Yes.
So each copy of Chrome out there is sending you back data about IMP, or is
it depends on your opt-in settings in Chrome.
Okay.
Cool.
And when you said it's an overall responsive, so if there are like a couple of things, like a couple of buttons, couple of clicks, then is it like an average time, or like how are you making sure like this has to be between this time or so on? Yeah.
We looked at a bunch of different ways to kind of aggregate if there's one page load and a bunch of user inputs. And what we ended up taking is like a very high percentile, which is usually most pages have fewer than 10 interactions, and we take the highest. If there's over 50, we end up like dropping one every 50, so that it's essentially the 98th percentile. Does that make sense?
Yeah, that makes sense. Thank you.
Anyone have any general questions, not just IMP based, but maybe some from LCP?
One question I just thought of while we were talking about INP actually was, how do you deal with web applications that might be debouncing user inputs that, you know, are coming in faster than you could display it, but might be coming in faster than, you know, a normal user experience would kind of dictate?
Yeah, so you're basically using, and we actually have like a code lab for INP. If you Google INP code lab, it actually talks about specifically using debouncing to optimize like typing in a text box. So I'll give that example, right? Like let's say you have a simple text box suggestion, right? And you have to run some JavaScript over some huge dictionary every key press. And use a technique called like debouncing to delay it. INP is just trying to see like how fast do things paint to the screen. So when you're typing, you actually really care about like being able to see the keys that you type. And so we're optimizing for that, like being able to kind of get that immediate response and not necessarily like how fast does your suggest box show up. Does that make sense?
Yeah, it does. I guess so. Like in those situations, is your INP kind of limited by whatever your debounce interval is? Like if you're debouncing user inputs every 200 milliseconds, does that kind of set an artificial floor for how low your INP could go, theoretically?
I think so. There's so much. You should look at the code lab.
Okay. Yeah.
There's like many steps that you can go through to like break up work and reset. It gets complicated.
Okay. Cool. Thank you.
That also kind of assumes that the text box is the only input on your site, right, or on your page.
Yeah.
So like, there's also the possibility if you have buttons, if you have other inputs, that like you can definitely artificially push that down.
So it gets more complicated, is what
Yeah.
you're saying.
Yes.
Well, one thing I wanted to point out real quick is that we actually, when we wrote INP, we found some issues in Chrome, especially around typing and doing some unnecessary work. Basically, our scheduler didn't prioritize showing that key. Mm-hmm. And we found an engineer to do an optimization in the scheduler that did prioritize showing the key presses back. And on desktop, it was like, it was an improvement to 99th percentile typing rate. And we actually saw users typed more just in the experiment group when we launched that than users in the control group. So it is an important optimization to make.
Cool. Thanks.
Cool.
I have a question.
Oh, sorry, go ahead.
Hi. I'm more of a general question. I'm curious about the automated kind of conventions to catch these things up front. How do you guys usually go about that, right?
So if you want to catch like, you made your site slower, like how do
yeah, exactly. Like INP and all these things. Like I'm curious about the convention you guys typically follow.
That's a great question. So a lot of people do performance monitoring, right? They start in the lab, right? Like maybe you do like a lighthouse run or something like that, or you do a lab run to measure metrics, like not like total blocking time, for example, is like how many long tasks, how do long tasks add up during page load, and that's a big correlate for INP. So you can run lab tests on every commit, and that'll catch it very fast. The larger sites use kind of like performance-sensitive A/B testing. So instead of the kind of A/B tests where you load it on your web page and it pulls in from the server, like the server actually would send like your new version and your old version to different users. And that's really hard to set up, but that's kind of the best way to catch regressions. That's how Chrome catches most of its performance regressions.
Yeah. Progressive rollouts also is a good way to you know, kind of A/B test.
Yeah, canarying is a really good.
Yeah. The unfortunate thing is so many of us developers have like M3 Apple laptops, which does, you know, kind of destroy these metrics to some degree. And it's not the experience of the typical user, for sure. I definitely encountered that building my own app. I like loaded it on my laptop and I'd get a really good number. I'd load it on my phone. It's a very different number, that kind of thing. So staging environments is another one. I also know that you can run synthetics and get like web vital information based on the synthetics you run. And doing that on like a staging environment or a pre-prod or something like that will give you like at least a decent idea. It's the hard part is that, at least I find, it's really hard to simulate every single possible user that could use your application. So to some degree, putting it out in the wild, even in like a progressive rollout or a feature flag, is probably your best bet to get like an accurate test to see what changes have actually made.
And then RUM solutions usually do like alerting, so you can see it. Hopefully, they'll help you split by like your different, like your canary or your old version, or
Yep.
Also breakdown, right? Like again, is it the TTFB that regressed or something after?
Thanks. One last question is, okay, so right now we're kind of in an environment where leadership tends to care about revenue generating. So I'm curious, at your level, how do you tend to translate the importance of these stuff to leadership in an environment where they care about revenue generating? How do you get that buy-in?
So there's a lot of studies online if you want to take a look that correlate performance and core vitals metrics to business metrics like conversions, bounce rates, abandonment rates. Content Square just put out a study of 1,000 sites, and they looked at the IMP, and they found that users with good IMP had 25% higher conversion rates than users without good IMP. There's already a lot of studies out there that you can point to. WPOstats.com has like an archive that you can look at. Also, if you go to web.dev, Google has a bunch of case studies on core web vitals. If you're able to get the access to the data, what I've seen work a lot and what I've seen RUM providers do a lot is they basically do this chart where they say, they take all the different sessions, right? And they say like, okay, we'll make a histogram, like take LCP broken down into buckets of 100. And then for each bucket, what was the conversion rate of the people in that bucket? And what you usually see is like the LCP is low, the conversion rate is high, and then it crosses. So if you're able to get that kind of data, it's super helpful.
All right.
It's funny that you bring this up because it's actually like one of my follow-up questions. So I really appreciate you doing that for me. I actually asked Annie right before this if she could kind of rank the actual vitals by importance in terms of business value, which is a little bit unfair because it's like asking her to rank her children. But I think the order was, and correct me if I'm wrong, is LCP tends to have the highest impact. IMP would be second, but again, it's like 3 months old, so still TBD. And CLS is just like the hardest one to like actually make that correlation, right?
Yeah, so CLS, the more people are interacting with your site and the deeper they go into it, the more chances they have to have a layout shift. So then like a raw correlation can't always like show you like split out causation and correlation.
All right, thanks. Appreciate
it. In a SPA application or any application where page transitions are happening on the client, like when are the web vitals being measured? Is it just that initial page load? Is it on page transitions?
So LCP is only measured on a hard navigation, so the initial page load, and then CLS and IMP are measured throughout. We are working on improving our APIs to better detect single page app navigations.
Is that basically soft navigation?
Yeah.
Gotcha. We have time for one more question if anyone has it. Go ahead.
Could you just talk about monitoring the performance of a WebAssembly application?
Oh, wow. That is a great question, which might be a little bit specific. What I would do is really, what we tried to do with Core Vitals, right, is we started with like, what is the critical user journeys? And for us, it's, page loads, interactions, and things like that. But I think for WebAssembly application, it's so hard to say, right? Because I don't know what is a WebAssembly application intended to do. It can do anything. So really figure out like what are your critical user journeys, and then start with like how can you monitor those. Like we have a bunch of APIs. Like instead of just having the metrics for Core Web Vitals, my team also works on web performance APIs. So there's APIs that will tell you navigation timing will give you all the different checkpoints in your navigation. Resource timing will do that for individual network resources. Event timing will give you not just the IMP, but the individual user interactions, like what were the timings on those. And element timing will tell you like when any image or text painted, not just what we considered the LCP. So I would design like what's your user journeys, and then take advantage of web performance APIs to really map those to critical user journeys that are specific to your app. Does that make sense?
Cool. I think that's time, everybody. I think I'm contractually obligated to tell everybody to take the session survey. And thank you so much to listening to us for the last 40 minutes.
Yeah, thanks a lot.